Hi everyone, we are Team 404. When we first started this project, we wanted to create something that felt competitive, social, and fun to watch. As we explored the theme of online influence, we became interested in how opinions spread on social media. It often starts with one person, then more people join in, support them, and help them message grow. That idea became Cloud Clash. In our game, two players compete against each other, while the audience can support one side and influence the outcome. We wanted to turn online attention into a physical experience that people could see, hear, and interact with. Through light movement and audience participation, Cloud Clash brings the relationship between leaders, followers, and online influence into a cabinet game. During the implementation, the biggest challenge of Cloud Cache was not making one module work, but combining all parts into one stable physical installations. Because of the limited budget, we changed from expensive step motors to cheaper and lighter N20 motors. But the delivery delays and the stock issues reduced our making time. System integration was also difficult. The heat sensors, audience buttons, LEDs, and motors all needed to work together. Because the wiring was complex, loose power or GND connections often caused problems. We also had to 3D print and adjust the structure many times. After many rounds of the testing and fix, we finally brought the system together. Now, let's see Cloud Cache in action. Hi, I'm Boan. In this part, I will introduce the technical details of our project. My main responsibility included building the two strike modules and developing the lighting system. This is the strike module I built for our interactive installation. The outer structure of each module is made from 6mm transparent acrylic sheets. Inside each module, the main electronic components include an Arduino Uno R4 Minima, a low cell, an HX711 amplifier module, and LED strip. The low cell works with a 3D printed force transfer structure to detect the impact force more consistently. The HX711 converts this signal into data that Arduino can read, so we can identify whether the player hit with the correct force. In the code, the system first calculates the background noise from the first 10 readings. When the hitting force is within the design range, the module gives a light feedback and sends a success signal to the middle, which then control the lighting and the mechanical movement.
So I work on this energy support machine. Our idea was really simple. We want cheering is feel like actually powering the machine. So as people cheer louder, the LED strips, the moving parts, and the energy bar all react. To make this work, I used the microphone mode, LED strips, and 3 surf motor controlled by one Arduino. I also used 3D printing for the moving parts and laser cut acrylic for the housing. One of the biggest challenge was redesigning the housing. I start with an MDF version, but later had to rebuild the whole thing in acrylic. And fit everything into a very limited space also a challenge. Another was about background noise. To handle this, the system listened to the environment for the first few seconds after startup and automatically adjusts to the background sound level. After a lot of testing and redesigning, it finally felt like the audience was actually powering the machine.
Hi, I'm Yang Qing. I was in charge of physical output of CoClash.
This is our main lifting unit. It uses an 20 motor to drive a lead scroll, so the structure can just move up and down. To find a stable solution, I test several early ideas. I tried crank, camshaft, and gear-based structures. In the end, I choose the lead screw structure and built it from scratch. I spent a lot of time changing the 3D model and testing the size. The parts had to fit well, or the movement will be too tight or too loose. For the final vision, the outer housing was planted in PLA and the lead screw parts were planted in PETG, which can make them more stronger for repeated movement. After one unit worked, I copied in 9 times to create a wave structure. To avoid losing breadboard connections, I used terminal block strips to connect the power and ground lines in parallel. This made the wiring cleaner and made the final prototype more stable.
Looking back, our biggest takeaway is that because the mold keeps going through different iterations, we finalized the physical form too late, which made part source and integration extremely rushed. We also hesitated on the project scale. Limited by cost, we almost compromised on a smaller vision. However, the teaching team pushed us to realize that an interactive installation needs visual impact, which keeps us going for the current Kavinault scale. In the future, we will conduct key risk testing much earlier. Prioritizing power testers and module integration will ground our design sooner and reduce the engineering pressure in the later stages.